Hello and welcome. Thank you for joining us for today's webinar sponsored by Artel, entitled How to Choose an Automated Liquid Handler, Tips and Tricks to Help You on Your Way. My name is Travis Scherset, and I'll be moderating today's session. In a moment, I'm going to introduce you to our speaker, Dr. Nathaniel Hintz, but before I do, I'd like to go over a few things. Following this 30-minute presentation, we will have a 10-minute Q&A. Please feel free to submit questions at any time during the webinar. I'll be monitoring the chat throughout, so if you have a question, simply type it in the chat box, which is located in the control panel, or click on the hand icon to raise your hand, which is also located in the control panel. I also want to make you aware of the handout section, where you can download materials relating to today's presentation. We have included our poster entitled Troubleshooting Automation, as well as popular links and today's slides so you can reference if you need to. To ensure the audio quality, we have muted all attendees until the Q&A session. Lastly, this webinar will be available on demand on the Artel website a day or two after the presentation, and we'll email you a link to it. Today, Dr. Hintz will be covering information on important considerations leading to choosing an automated liquid handler, the difference between manufacturing specifications and your requirements, as well as why it's critical to measure the performance within the context of your assay. So, without further ado, let me introduce you to Dr. Nathaniel Hintz. Nat, take it away.
All right, thank you, Travis. Welcome, everyone. I'm going to minimize my little screen there. And what I'd like to do today, I'm going to welcome you to our applications webinar series. And yes, this is part one of a series. We're going to be talking about how to go about choosing an automated liquid handler. And this is really geared for folks that are somewhat new to the automation realm or are thinking of purchasing a new automated liquid handler. And so I'll be sharing some tips and tricks with you to sort of help you out. What I'm going to do is try to get this done in about 30 minutes. Travis put me on the hook there, so let's go ahead and get going on that. And then for today, like I said, we're going to talk about choosing an automated liquid handler, some of the important considerations that go into that, and then once you've purchased it, what you should do. And then we'll talk a little bit about using Artel's MVS platform and how to optimize the pipetting workflows. And then we'll have a quick discussion at the end. And before I really get into this, feel free to raise your hand or pop questions in. I'm happy to take these live as we're going along. I won't be able to see the hands pop up, but Travis is going to be watching. And he'll just go ahead and interrupt, and then we'll go ahead and try to field some questions, or we can wait until the end. It's up to you. So we're all here today because we're interested in automating an assay workflow, and really there are three primary reasons to do that. Scaling up, and most people are doing that to really scale up. It's to increase capacity, free up operator time so that people can be doing other things like developing the assays. Also, especially over the last year, the amount of automation has completely exploded in the industry, and it's all around quality. So we got scale up in quality, and we're talking about improving accuracy. We're talking about minimizing variability. And improving reproducibility. And the nice thing about automation is it doesn't get tired, it doesn't get fatigued. I mean, parts wear out, but the system can keep going and going and going. It doesn't get interrupted. It doesn't get tired after a late night of watching NCAA tournament basketball. And then, the third reason, sometimes people need to consider safety. It's really about reducing exposure to dangerous reagents or clinical specimens. So that's another, third tier of automation reasons. And when we think about automating an assay, there's a number of considerations that we're going to go through, and some of these I'm going to drill down into over the next few slides. And really, I'd say not maybe the most important, but certainly very important is the budget. When you think about automated liquid handlers, if you're new to it, it can cost anywhere from under $10,000 for a fairly simple system, all the way up to more than $250,000. or it can go, can skyrocket up depending on what it is you need to do. But we'll be sort of thinking about automated liquid handling platforms versus full robotic systems. And then the other part of the budget that I want to highlight here, and I'll do it again after about a minute or two, get what you can afford. A lot of times people are really trying to minimize what they spend, but we need to think ahead, and we're going to revisit that. And I'm not saying be wasteful, but think about ahead and what you might need to get it now before it gets more expensive to add it on. Then there are facilities considerations. That's the space, where it's going to sit. I think that's a pretty obvious one. I've got a bench over there and I'm going to just plug it in, no problem. It's utilities, I think, is really the big issue that a lot of times people overlook. They're always in the site setup documents, but a lot of times people think you can just plug these in. But many times a fully automated system requires air or nitrogen. It might require vacuum. It might require a couple of power sources. And then you have to think about the computer, where's that going to go? So it's not just space, it's about the actual utilities. And I've been in so many times where I've had a piece of equipment brought in, and there's a lot of power utilities work going on once it's installed or once it's set up. And then, other part of the facilities is environment. We got to think about that. And we're going to drill down so I can show you a couple of examples what I mean by that. Another consideration is expertise, and it's the level. And what I mean by that is if you think about the user, is it going to be a dedicated engineer, or is it going to be an occasional user, like a group of occasional users? There's a big difference in the level of expertise that's required on those. Whereas everybody's going to require training, but the dedicated power user, that person, everyone's going to be relying on to make changes to the software and to the scripts. So that person's going to require additional training. And then there's the service and preventive maintenance schedules. Is there an in-house service group that's going to do that? Are you going to do it, or will you contract it out to either a third party or a service program through the automated liquid handler manufacturer? And then finally, functionality. Plan ahead. And this kind of ties right into that budget. Actually, they're all kind of tie together. Think ahead. If this is going to be a dedicated task and it's going to be that way for a year or 2, 3 years, then it's perfectly fine. Get exactly what you need. But if you are thinking multi-use and there's going to be other people that will need to plug an assay in or maybe do some compound reformatting, you might need some flexibility. So you'd want to build that into the purchase now, because again, it's a lot less expensive to do it now than it is later, typically. And again, I've just highlighted here in red sort of the main takeaways here. Get what you can afford, and think about the utilities. That's like incredibly critical. And think about your user and whether it's going to be a dedicated engineer, or is it going to be an occasional user, a group of occasional users, and then again, plan ahead. The other part that we need to think about is the lab space itself, and I alluded to this earlier about the setup. But it's not just about, I have an empty bench over here, let me put it there, but you really want to think about your workflow. And it's about all of the inputs and outputs for your automated liquid handler. And what I mean by that is the inputs are you reaching into it and setting up your reagents, plates, and other, loading the consumables into this system. Or maybe there's occasional transfers in and out of there if it's semi-automated. So you want to make sure that you're set up for that there's appropriate bench space next to you where you can have a staging area to put your equipment and reagents. You need to think about lab traffic too. Just because I have an open bench over here, that's fantastic, but if you have a lot of people that are normally walking in and out, if it's by a main door, that could cause a disruption. It could cause airflow disruption. So you want to think about those kind of things. And I've got in this particular slide, there's a couple of references on the Artel website. It's thinking about this lean approach. And it's really, it's sort of a change in the way we think about it. Don't just get something, but think about the way you're going to use it, and how you operate as a group or a lab or as an individual. So this really, the idea here is getting the right automation, get the appropriate thing for your situation, and that really considers the material flow, people flow, and information flow. So again, I gave that example of things going in and out. If you have no staging area and you have to bring this pile of plates over and stuff, that can be detrimental to fully automating or being successful. The lab environment, I alluded to this as well. There's so many things that can affect your ALH performance, and the temperature and humidity are a couple of big ones. And I have seasonal here in parentheses, and I did that on purpose because if we think about, so I live in North Carolina. It gets pretty brutally hot and humid during the summertime here, even though we have air conditioning in the buildings. That can actually affect the humidity and sometimes temperature inside the building. In fact, I remember many times in the laboratory where the facilities would overcompensate and it would be freezing during the during the summertime. So again, think about these kinds of considerations. There's barometric pressure, that's altitude. We can't do a whole lot about that. But just be aware of it. And then the other, probably the two big ones here are air handling. So that's location of vents, and then light. And what I'm going to do is drill down into these. And again, there's a nice reference here discussing some of the impact of these environmental conditions. When you think about air handling, I have just a diagram of a lab. There's the vents up above, so they're blowing air in. That's what's doing the cooling and heating. And then some labs are set up also with the chemical fume hoods, and these are taking their exhaust fume hoods, and they're pulling the air out. And when you're setting up an automated liquid handler, you've really got to be aware of your surroundings, because these can have a dramatic impact on the performance. You can there's cooling or heating unbeknownst to you, or if you've got airflow, you can actually cause evaporation of your reagents and biologicals and whatever you're working with. So it's definitely a big thing to consider. I'm not saying that you have to reroute all of your air handling. I'm saying make sure that when you're working, when you're buying a new liquid handler, that you're looking up and looking around to keep this in mind, and then try to adapt appropriately. Light, that's another big one that people typically overlook. There's the ambient, that's your laboratory lighting. If you set up a system under all these incredibly bright lights in the laboratory, some assays are very sensitive. Fluorescent molecules can photo bleach, and there are some assays, the alpha screen technology is subject to some of the light effects. That's on the assay side, but on the liquid handling side, you see over here to the right and then sort of to the left here in this image of this laboratory I've circled around these windows. If you think about the sunlight coming in, and let's say I've put my liquid handler off to the right and my big automated liquid handling platform, and the sun happens to track in there, and this might be a south-facing window, and I got the sun beating on that all day. That's going to heat up the system and the surroundings. And we all know this, sitting in a lab, working in a lab, if you have exterior windows, the sun can start heating things up. So again, be aware of that. A lot of times people like to put automated liquid handlers either in the center of a lab where they don't have that direct exposure, or on a windowless wall. And again, I've seen so many cases of this being botched, and it's a real thing. Or you could put up window screens. If we think about the liquid handlers out there, there's a ton of different makes, models, and a bunch of options. So we're going to talk about a little about that right now. You got the large systems, and in this particular example, you can see there's there's grippers and things that can do a lot of different things. There's reagent bottles to handle bulk solutions for washing and whatever. And when you think about the the advantages to a large system. You've got the flexibility. You can run very complex protocols. So this one might be set up for an ELISA, let's say, or maybe some next-gen sequencing. But the issue is they take up a lot of footprint, bench space. Sometimes they come on their own wheel cart. If you do get one of these big ones, you've got to make sure that you've got the right bench set up. There are a lot of benches out there, and they're not all created equal. Some of them can handle it, the weight, some of them can't. Sometimes people like to sit set up in a mobile lab, which is great. They're actually heavy-duty tables that minimize vibrations that you'd want to consider if you're going to get a heavy piece of equipment. And then on the alternative side are the smaller systems. And again, the advantage of those is they got a small footprint. They can fit in many, many places. They're not as expensive, and they're typically a little easier to use. But they're a little bit more manual in some cases. So in this particular example, you see it's just stamping out reagents, basically. So you would have to be that interface, and you'd be moving the plates around, and there's typically less options. And then if you think about the design of some of these, again, I would say stable. It's got a small footprint, but that doesn't mean you should have any less stable of a lab bench. I've seen many, many cases where people try to set these things up on the inappropriate bench, and then you got shaking and moving all over the place, and it wreaks havoc on precision and accuracy for your assays. If we think about the pipetting formats, there's any number of things. There's 8-channel if you look at the left here. And those are really great for serial dilution. So if you're doing calibration curves, or you're doing compound dilutions across or down a plate, that might be a great option. If you're interested in hit picking or reformatting from tubes, let's say you have some blood samples or saliva swabs, you need to reformat that into a plate. These are the great option right here. So these would go into a tube and then put it into a plate. And then we've got the 96 and 384 channel versions. And again, these are for plate stamping. So if I need to move contents from one plate to another, like a stock plate to an assay plate, that might be one way. And you have washing, and you can do full and partial plate transfers here. And so these are the common ones. There are other liquid handler types out there. These acoustic dispensers, but that's not really the point of this talk today, is to cover everything. I just want you to be aware of the options. And when you're considering purchasing, think about what your needs are going to be. Not just, I need an automated liquid handler. It's what it is you intend on doing. And if we think about, I kind of mentioned this in a previous slide, it's about all these options. And I will tell you that the more sophisticated automated liquid handlers, they can accommodate anything, pretty much anything that you see on this screen here. You got plate grippers, incubators, wash stations, plate shakers, heating, cooling. If you're into qPCR, or RT-PCR or NGS type of work, magnetic separators are going to be there. And you got labware holdings, that's reagent troughs, and that's tube holders, those types of things. So when you talk to a vendor, they're going to ask you all of these questions because they want to make sure that they sell you the right stuff. But this is why they're asking, because a lot of these are options. You don't need it. But this is where I was going at, trying to describe earlier. When you're thinking ahead, it may be cheaper to get the options now if you think you will be using this equipment later. So in other words, if you're doing an ELISA, which you don't need a magnetic separator for that, but you're planning on doing some qPCR work in the near future, think ahead. And then you might want to include the magnetic separator and then maybe a plate gripper or something like that. So again, this is where you want to think ahead, and this is what differentiates a lot of the liquid handlers. It's about these options. So that's kind of thinking about all the, probably scaring some of you to death. It's like, oh, I didn't know all of this. Well, I'm not trying to scare you. I'm trying to educate you. And with this slide here, I want to just kind of point out the manufacturer. They're all going to provide you with pipetting performance specifications, and this is just an example. This isn't tied to any company in particular. But what you'll see is the tip size, and then the volume dispense, and then what they can guarantee the precision will be, and then the trueness, which is a reflection of accuracy. So the point I want to make here is, just because the specifications are on here, and this is what the manufacturers guarantee using their tips with a specific liquid, which is typically water, that's what they'll guarantee. That's the performance specification of the system. It's not necessarily true for your assay, and that's the differentiator here. These are great numbers, they're fine and dandy, but you need to get something that matches up with your assay, and we're gonna talk a little bit about that in the coming slides, starting with this one. So if when I think about assay, I think about what it is that you need to be able to do, and it's about understanding your workflow. And my guess is out of the attendees, if you're new to automation, which I hope you all are, you're probably the biologist, you're the assay developer, you have a good understanding of your workflow. That helps you define what you need for your automated liquid handler. And again, this is why a good automation liquid handling vendor will work with you on this to try to understand. That's why they ask you the questions. And if you understand your assay, you can start to pick out your environmental constraints, if any. So if I know I'm working with a particular assay that's sensitive to light, I need to consider that. If I am working with an assay that's got viscous solutions or volatile organics or aqueous or protein-based solutions, I need to consider different liquid classes and the ability to change some of those. And again, you can kind of read through this, but when I say think about your assay, really understand it, this is what we're getting at here. If you have a mixing protocol that you have as in your manual station, we need to be able to replicate that on the system. And again, time sensitivity. Some reagents are very time sensitive. Once you add reagents to an assay, you've got to get these things pretty quickly into the detector. And then also, don't forget to define what's acceptable to you for your assay performance. A lot of times people forget about this and they'll get all this other stuff, and then they come to realize, like, well, I have very demanding assay performance criteria. I'll never be able to meet it with this particular liquid handler, but by then it's too late. So, think about this ahead of time and try to come up with your specifications ahead of time. And just a note here that just popped up. This factory acceptance test and site acceptance tests, they don't guarantee that the automated liquid handler is going to work for your particular workflows. The only way that it does that is if that site acceptance test has been designed to do so, and that's usually with a negotiation between you, the customer, and the vendor. But like I said, a lot of these site acceptance tests, they have nothing to do with your assay necessarily. It's about performing in the field once it's set up. And again, these are typically associated with setup and get that stuff installed properly. So just keep that in mind. Just because there's a FAT or an SAT, that doesn't guarantee that it's going to work for your assay. Speaking of your assay, if you're in the market, the recommendation is take it for a test drive. Sometimes you can bring in some of the cheaper, I shouldn't say that, the less expensive models, because they're smaller, they're more portable. Bring it in for a demo. A lot of times these companies will come in, they'll set it up, and you can test drive it. If you have a colleague down the hall, another building, go try it out. And then probably 90% of the manufacturers out there have a demo lab that you can visit. Most of them want you to come and visit, and then you can go ahead and take a test drive. Because a lot of these bigger, more expensive systems, they're difficult to ship out just for a demo. So that's why they have these demo labs, so you can go and visit. And again, you need to really make sure that it works for your assay. Don't pay attention only to the specifications on the back of a brochure. You need to be able to test your volume. So to do that, test your liquid types, and sometimes depending on the laboratory, you might even be able to test your assay if you're lucky enough. I can't guarantee that one, but you should at least have a good concept of your liquid types and the volumes that you're interested in. So once you've got your system set up, It's the automated liquid handler company, the service engineer has come out, or the field engineers come out, set it up, everything past the specification. That's just the beginning, I'm sorry to say. You really need to think about several aspects here, and training is one. The obvious one is the ALH itself. So sometimes it'll be a couple of days, they'll throw it in for free, you pay for extra. It just depends on the level that you need. And then there's manual pipetting training, and we're going to talk about that because I know some of you are thinking, Nat, this is about automated liquid handlers. I'm trying to get away from manual. Really, the whole idea here is about transitioning from manual into automated liquid handling platforms. And we're going to touch on that in a little bit here, a couple of bumps down. You need to qualify your labware, tips, reservoirs, whatever it is that you're using. Some plates could be another one. And I bring this up because a lot of times the vendors will have the tips that they recommend, and you're going to find that they're typically more expensive, but they work. And then, so what usually people will do is try to cut costs and then go to alternative manufacturers. So this is where it really becomes important to qualify your labware. Again, once you've purchased your system, you still need to optimize your liquid class. This is about defining your specifications. You want to mimic your reagents to the best that you can, because again, these are fluids. They're not all the same as water. Ethanol behaves very differently than water. 20% glycerol behaves much differently. 150 milligrams per mil monoclonal antibody in solution behaves much differently than water. So you need to keep that in mind. And this is, I can't overstate how important optimizing your liquid class is. And then, so you've got some of that taken care of. You want to develop a verification plan, and this is really about making sure that your liquid handler works properly. This is deciding on the frequency of testing, the volumes of testing, and the number of replicates. And sometimes, as people put this as part of a trending program, so you can monitor performance over time, and making sure that things are behaving properly. And then you want to verify your application. And so I'm going to tie this right back to the training here. It's writing appropriate scripts, and it's about translating that manual to automation setup. And what I mean by that is, if we're pipetting aqueous solutions, we're manually pipetting, my multi-channel pipetter. When I get, I'm pipetting aqueous, I know what to do. I'm just doing it on my autopilot, and then I've got my PCR master mix. It's a thicker, more viscous solution. When I'm pipetting, I make manual adjustments, just like that, hand-eye coordination. We just do it intuitively. We start slowing things up, and then we come over and we aspirate and dispense a little bit slower. We're paying more attention. An automated liquid handler doesn't do that. It does what you tell it. So what we're trying to do here is mimic what you're doing manually. And the reason manual pipette training is important, I've seen so many cases where the automation is working fine, but that manual to automation transfer fails because of variability issues and accuracy issues. And there's been so many cases where it translates right back to that manual pipetting. The person was doing it in some weird way, and the assay was working for them, but then when it was automated, that's when the problem became apparent. So again, make sure all pieces are working properly before assigning blame. So once you've got all that taken care of, you're ready to hit the ground running. Assay design. So if you think about your automation, there's a few things that you can consider. If you design it properly on the automation system, it can actually help you. Transfer volumes. Let's think about those small volumes, less than 5 microliters. They can be difficult. It's doable. It's done all the time. So don't misunderstand me. In fact, it can even go less than a microliter. But if you have a choice, if you're not sample limited or cost limited, you might want to think about maintaining a little bit larger volume. But you may not be able to if you're dealing with patient samples. But again, the small volumes, they can be difficult. It's a lot easier to do larger volumes. The plate layout. This is a balance between a simple layout and what I would call scientifically rigorous. And what I mean by that is if you have an assay plate, if you wanted to be like perfectly scientifically rigorous here, you would have random compounds or samples and controls and standards placed throughout the plate just randomly. And then you would deconvolute that once you've run your assay. But most times people don't do that because it gets a little bit complicated to do that. So sometimes what people will do is put controls on one side and then samples in the middle. So again, there's a balance there. So keep that in mind. And then this isn't really assay design, but it's a deck layout, so it's kind of similar. It would be sort of mimicking how you would set up your bench. So if you have reagents on your bench and you're assembling an assay, it's rare that you would take reagent from over here to my right hand side and then aspirate and then travel over reagents 2 and 3 before you get to your plate, because you can drop in those and you can contaminate. So you have to think about that in your deck layout as well. That's about setting things up appropriately so you're minimizing contamination, and then you can also maximize speed. So again, there's a nice delicate balance.
So hey, now Travis, real quick.
Yeah.
Just giving you a heads up on the time. We're just at the half-hour mark.
Okay. We're gonna kind of cruise along here then. I mentioned the labware. This is incredibly important, and it said that most manufacturers will sell their own tips. They'll make and sell. Those are really the best option, but there's a lot of vendors that sell them as well, and they're typically less costly. They vary in quality, and you got to qualify those. And what I wanted to talk about here is a pretty easy solution to qualify that. I'm showing in this example here, we've got the manufacturer has recommended their tips, and we'll call it lot 1. It's got this performance here. And then this is a lot number 2. So they got very similar performance, slightly different precision, but within a specification. And then we're thinking about switching over to a bulk universal tip manufacturer. And as you can very clearly see, that the precision and accuracy are way off on this. Now, you can run your assay to determine this. That can be costly. It'll take a lot of time. Or you can perform this on Artel's MVS. And I'm going to talk about that coming up very, very shortly. This is a teaser alert. I will be conducting another webinar a little bit later, and we'll talk about that. So we've got another companion webinar coming up to talk about this. When we think about pipetting verification, we want to make sure that if we do anything to that liquid handler, we have a way of measuring it, the performance of it. So this would be the IQ, OQ, PQ with the emphasis on the performance qualification, calibration checks if you crash it and you fix it, or if you relocate it, that type of stuff. You want to make sure that it's performing properly. And again, we're getting into the measurement side of things here, which I'm getting very excited about. And then there's this so-called liquid class development and optimization. This is really about making sure that using your solutions that you get the best out of your liquid handler. And again, this considers viscous solutions, cold or warm solutions, those types of things. And basically, how do you do that? I'm not going to tell you on every single liquid handler, but in general, you start with basic transfer parameters. These are probably what the vendor provided you with. You watch it pipetting a few times. If it looks good, move on to optimization of your volume. If it doesn't, that's when you start getting into some of these adjustments here, the pipetting speeds, the air gaps, and air aspirate and dispense heights, those types of things. And then once you've got that locked down, this is the kind of data that you can see. If we think about liquid class optimization, the panel to the left, we've got basically the default liquid handling or liquid class, and it's under dispensing by about 25%. And then after it's been optimized, you see it's under dispensing by 0.04%. So we've drastically improved this through this optimization. How do you do that? It's basically you select 3 volumes and you plot target volume versus measured volume. And most automated liquid handlers will have some sort of, if it's a linear calibration, they'll have a scaling factor or something similar to that, which is the slope, and then the offset volume, which is the typically the y-intercept. You plug that into the appropriate spots, and bada bing, bada boom, you got this pre-adjust. If you look at the measured volume, it drops down. We've improved our relative inaccuracy, and you might improve, go on and tweak a little bit, but it's pretty straightforward in most liquid handlers to do this. Now, how do we measure this stuff? That's probably an important consideration, and there are a number of ways you can weigh the stuff out gravimetrically, absorbance dyes. A lot of times people use those techniques, fluorescence, or there's this dual dye ratiometric technique. Whatever you choose, I would encourage you to make sure you consider a number of factors here highlighted to the right here: ease of use, measurement robustness, the volume range, all the way down to regulatory compliance if you need. And this isn't a mistake. I'm going to be talking about the next step here in this Artel MVS technology, and this is this dual dye ratiometric technology. And it's by no mistake that every single one of the columns had a little plus in it because this does really tick all of the boxes. And basically you dispense this red dye, and that's the quantitative part. That's what's going to do your measurement side of things. That's the volume that you're interested in. And then there's a diluent side. That's what brings it all up to a sort of a equal volume, so they can be read in these 96 or 384 well plates. And that happens to be non-quantitative. And then there's a couple of photometric measurements here. You're reading absorbance at 520 and 730, and you plug it into this derivation of Beer's law, and you end up solving for volume of sample. And again, I'm oversimplifying it here. There's a lot that goes on behind the scenes, but in a nutshell, in fact, you see the small a sub b and small a sub r. That's where a lot of the work has gone on, and that's the traceability side to Artel's measurement. Those are coefficients. They're related to concentration. But anyway, it's a fairly straightforward measurement. This is the workflow. We add the red solution to the plate, add blue diluent, up to the prescribed volume. This can be switched around. You mix it, and I'm going to bring this up this is a very important part of this. This is a validated plate shaker because we got to get all that stuff mixed up. And I don't have a teaser alert note here, but we will be talking about mixing in your assay and how to optimize for that in about 2 months. We do a plate read, and you get your report. And what's nice about this is you get full plate statistics, you get individual readouts. You can look channel by channel, dispense order, and then you actually look at precision and accuracy. And some of these other techniques, precision is easy. The accuracy part is really difficult. So wrapping it up, I know Travis is chomping at the bit here. Just a couple of things for takeaway. Keep it balanced. The more complex the system is, the more opportunities there are for errors. So, or failure points. So don't just get a complex system. Make sure that it's what you need, if that's what it is. And don't be afraid to incorporate manual steps into these automated workflows. It actually might be easier and quicker than automating everything, because anything can be automated, but that's where it becomes very challenging. So, understand what it is you need to do. And then finally, let's plan for tomorrow. And don't just think about the here and now. Think ahead a year or 2 years, and that'll help guide you on selecting the appropriate automated liquid handler. Well, I thank you very much for your attention. We can take a few questions here, and then just a little plug for the follow-up webinar on pipette tips and evaluating those, April 28th. Thank you very much.
Yeah, thank you, Nat. That was very informative presentation. It looks like that we do have a question here. It's regarding liquid class and biological matrix.
Okay.
For example, human plasma. They're wanting to know if there is a mimic liquid. They're saying that it looks like vendors don't like working with biological matrices.
Vendors don't like working with biological matrices because it's difficult. So there are some hybrid methods right now that you can do, and that's basically dialing in your liquid handler with aqueous using an RTEL MVS type of thing, and then combining that with a gravimetric approach, taking an average of serum or plasma. The alternative is, and I am going to put a plug in here, and the application or the production team is going to kill me for this, but we are working on a serum substitute. It's a good question, and just like our PCR mix mimics PCR master mixes, we're creating a solution that will handle the serum. So I think look for that in the coming months. That one I'm pretty excited about.
Thank you. It also looks like got someone, from Matthew Hahn, is wondering if manufacturers' liquid handling states a higher precision or accuracy than the MVS, how much discrepancy can you expect?
I don't think I haven't seen anyone do it higher than, and it's all about uncertainties. So the uncertainty measurements are, we've got that documented. You can actually pull that up on our website if one is interested. But I'm not aware of a liquid handler that has tighter specifications than what we can measure. But if it is a concern, it's not about what the instrument can do, it's about what you need. And that's where we typically see customers will have a need for much tighter specifications or not as tight as the manufacturer specifications. But I would say, either follow up with us and we can address your concerns on that. But I'm not aware of liquid handlers that have specifications that are tighter than what the RTEL MVS can deliver. Maybe volume down into the sub 10 nanoliter. Good question.
Yeah, it looks like he has a follow-up saying that the Integra Viaflows apparently quote a tighter tolerance.
It's entirely possible. It just it depends on what you need for. What I would say is you make sure that you have whatever your measurement tolerance is, it's capable of meeting your assay numbers. The manufacturer's specifications are great, but make sure that it meets your application numbers. That's the most important part. In fact, there's a lot of vendors out there that have specifications that are tighter than what you can than what you need for your assay, and then vice versa. Sometimes I see a lot of times people will claim they'll use RTEL's technology or gravimetric or whatever, and they can achieve tighter specification numbers than what manufacturers will put on their specification sheet. And there's a reason for that, that this is what the manufacturers will guarantee. So that's why you see some of these variances across the industry.
That's good, thank you. And thank you, Matthew, for the questions. It looks like we might have one more that is wondering if there's like a specific liquid handler that you would recommend over another.
I wouldn't, and there's a reason for that. I think you guys can, all of you can guess. Not only are we trying to be neutral here, but the real reason is it needs to fit your application. It's just, and this is why you need to test the liquid handlers. You need to make sure that it fits your applications, because we can pick out one that we've seen over time, based on our history and experiences, like this performs so great, but it may not meet your needs. It may not be able to mix appropriately. It may not have the components that you need. So again, that's something that you would figure out in part by understanding your assay workflow. There's a lot of good liquid handlers out there.
Yeah, it looks like we've got one more from Robert Lunston. He has hand raised. I'm just going to go ahead and
sure.
Oh, Robert, if you want to unmute yourself, you can ask the question.
Getting into comparing systems to low volume, but
Sorry, Robert, we seem to be having some problem, a little bit of trouble hearing you.
Probably type that in.
Yeah, can you type that into either the chat or the question box? Thank you very much. Saying not comparing systems, can you suggest a low volume system?
A low volume system. Well, it depends. So there are a lot of. I'll just tell you that, like, if you're looking at nanoliter and picoliter, a common platform are these acoustic dispensers, but there are a lot of arrayers out there. There's companies that specialize in these low volumes. So it just depends on what you mean by low volume. If it's like anything above 1 or 2 microliters, most liquid handlers can accomplish that pretty good. But I would say that if you're looking at much lower than that, there's actually pin tools. We didn't even talk about that, but those can go fairly low. But acoustic devices are these arrayers that have these piezoelectric dispensers.
Okay. Thank you
That's
very much.
a very non-committal answer.
Yeah, I think we've got time for just one more. And it's how would you go about validating a protocol where multiple source wells are combined in various combinations in various destination wells in an efficient way that represents the protocol?
So that's actually a very good question. You'd have to break it. You'd have to break the assay apart. And I've had discussions with this with some other folks that it's like, well, they want to mimic exactly what their assay is doing. And I would encourage you to follow up with me after this seminar because we can talk through it. But what I would do, there are ways that you can mimic. You could take it apart, and if you have multiple things going into a well, you could have one of the or maybe let's say you have 3 dispenses going into the same well. You potentially could have 2 of the dispenses doing diluent, and then the third would be doing a red dye, and then you could alternate that with the other dispenses in there. That's how I would do it, and I've been pretty successful breaking it apart that way. And that way, it goes to the same flow that you're working with, and you can get some pretty interesting numbers actually. But I'd say follow up with me after the seminar. I'd be happy to talk with you on that.
Sounds good. It looks like we are just about out of time. We do have some more questions, but we will be sure to follow up with those via email after the presentation if you would like.
All right.
I just want to thank everyone for attending our webinar. And once again, I'd like to apologize if we didn't get to your questions today. We will make sure that we address them. But also, as a reminder, don't forget the resources we have in the handout section. And have a great rest of your day.
All right, thanks everyone.